Hello again, this is Crystal from Open to Public HVAC Parts, and today we're going to learn how to test some limits and figure out how we're going to check and see if they're good, if they're bad, or maybe some other potential things that could be going wrong, and they might actually be doing their job. So let's check it out. For a lot of you, you probably have some sort of voltmeter. Obviously this is a clamp meter and I have some other nifty things on here I can use, but you probably have continuity on there, on yours somewhere. The easiest way to check and make sure that these limits are good, and you can have several different kinds of limits that might look the same or a little different. This one is what we call a rollout switch, which, as you can see, it's got that manual reset button right there. These are near your burners, and the job of that is if you get flame rollout, which is, indication of a crack in your heat exchanger, no bueno. When that happens, it's going to cause this to overheat, and that button's going to pop. But right now, what it should be doing is it should be getting continuity with little to no resistance. We're going to put our leads on each side of these and try to make sure when you're checking with leads, you want to get these edges to get a good reading. So that beep, that's a good thing. And we're reading 0.2, which is basically little to no resistance. That's great. And anything under 1 is good. I mean, some of the older ones might read a little higher, but a 0.3, 0.4, totally fine. Same with these. So every single one of these that are going to go in line to let your furnace know, hey, everything's cool, keep running. They all should be closed. Now there's a few exceptions when you get into air handlers and electric heating and whatnot, but with these, they should always have continuity. So what is a good way to tell when a limit is bad? And this doesn't work for all limits. We'll get to this special guy in a minute, your rollout switch, kind of answer a few questions about why this is different. But for now, if you don't have this little handy jumper like I do, which has a double-sided connection, male connection with a joint metal piece in the center, fantastic. So if you don't have these, you can put a jumper here, maybe some gator clips between your female quick connects, and figure out if that limit is the culprit. Check your automatic ones first, which these can be on your blower housing. Some of the older models have them on a plate that's kind of above the burners. There's these kinds that are on either on your blower housing or again somewhere inside. But instead of having that reset button, it's what we call an automatic limit. So it's not going to have that reset button on it because it's a secondary safety switch instead of your primary. But you do have one more limit that we call a high limit switch. Now some high limit switches, they can look similar to this. Some of them have maybe a longer butt, big booty duties, a little longer. I've seen some Linux models that have some similar ones like this, or they have a little wonky base that's similar to this, but the legs kind of go longer. But yeah, there are some similarities. Let's take a look at the high limit switch. Now, a high limit switch, you're not going to see this back part of it here right away, because this is actually the probe that goes back into your heat exchanger. What you're going to see is from the front. Some of yours, might be flipped this way, but it's going to have 2 prongs here, and it's going to be mounted on your heat exchanger, usually back behind the gas valve. Somewhere on the metal wall, you'll see these 2 prongs. These, like the other limit switches, are going to be closed right away. So again, when you're testing your limit switches, this one should be closed. Right. Some of these, I've seen some Yorks, really bizarre, or they're 5-inch. That's not very common. Usually, most of them I've seen are a 3-inch probe, and there's your disc limit right here, which causes the connection to open if it overheats. Some of them are 7 inches. I've even seen some that are 11 inches. Some older Goodmans have those, Amana. Once you've tested all these for continuity, if you're not getting continuity with some of them, they could be bad. And normally, they are. It's good to check just to make sure that maybe your meter's not broken or something like that. Also, especially with these types of limits, if you're able to get continuity after thumping them, they're bad. It's time to get a new one. So if you're testing it, you don't get continuity, and you thump it, and all of a sudden it's getting continuity, go ahead and replace that, because that, again, is no bueno. Testing limit switches can be frustrating at times because sometimes they can test good, and then the same problem happens where your furnace cuts off after it stays on for, say, a couple hours, or maybe you're having some sort of intermittent functionality where it'll come on for a few days or a week, and then it'll all of a sudden do it again, where it causes the machine to cut off. So there's other ways to test around that. A common way that techs do this is these are going to be normally closed, which means voltage is going to go through. It's going to have no resistance, so it's going to go through all the lines to the board and tell the board all systems go. A way to get around that, just to see what's going on if you're testing it, boop, and you're getting continuity, but you're still getting, say, the board blinking and telling you open limit switch. Fortunately, there's some models, I know of a few Linuxes that will just say open limit switch, but it won't tell you which one. As you can use these little gator clip guys to jump around it, or in a minute, I'll show you how to heat test it and see what it does. Pull your wires off because, they're going to be connected here on either side. Great. So you're going to remove those wires, and what this is doing is closing the circuit yourself. Here we can just kind of hook our gator clips on there, and these next ones are super annoying because they've got these little insulated tabs on them, which is super fun to try to hook anything on. And now we've effectively closed our circuit. So it's going to bypass your limit switch while you're testing. Do not leave it like this. It's a safety hazard. So we can do it this way. Or if you do have one of these, or you're a tech, or you just bought these for funsies, that's what this does. And it makes it super easy to connect them on either side, unless of course you have these plastic ones, in which case you're not going to be able to fit their big booties in there. Now that we know how to jump around these, there's an important thing you need to note before you go ahead and run it through this cycle. Most units on the blower housing have a safety switch. You need to make sure that that safety switch is depressed, whether you tape it, whether you have someone hold it down, before you turn the thermostat to heat. Or for some of you guys that are comfortable with jumping R to W for your heat, at the board you can do that. After you have it jumped around, unfortunately the only way to see which limit is bad is to bypass each and every one. Bypass this one, bypass your limit switch. Usually this is secondary, but some primaries can look like this. Bypass your high limit. And do what you need to do systematically, one by one, to find that bad limit switch. Once you kind of think you've found the culprit, you can take it one step further just to double check that it is actually that limit switch. And I'm going to show you how. And bonus, you get to play with fire. And just before we forget, make sure that before you start testing, you completely reset your power before you take down your door switch and all that. Okay, now kids, obligatory, don't play with fire. Don't burn yourself. it's good to have something like this to kind of hold it out so you don't burn yourself. So basically what's in here is a thermal disc with a pin. When this gets overheated, what happens is that disc pops up, kind of bubbles. And what that does is it causes the pin to go up through here, which opens the circuit, no longer allowing your electricity to come through. And it's not going to reset until it cools down. Every single one of these has a different temperature, and usually you can tell what temperature it is. Like this one here is L49. If it's a really low number like that, it almost always means Celsius, especially with limit switches. So just kind of go into Google and pop in what 49 Celsius is to Fahrenheit, and boop, there you go. So if you need to purchase one, you know what temperature yours sits at. Some of them have it along the lip here, and it can be a little hard to read. Some of them on these little small guys will have it printed here on the side, which makes it easier on the black part. But a lot of them, they put on this little ring right here, and it is super hard to read. So that's funsies. In any case, what we're gonna do here, and don't do what I'm doing here. I got a little mini torch. Just use a little hand lighter, one of those ones that you use for lighting candles or cigarettes or whatever. And we're gonna heat it up until that thermal disc causes it to open. So just exercise caution here. And we're gonna light it. Now with this one, I don't think we're able to hear it here. Let's just see what we got going on. Yeah, it's open. Okay, so you should not be reading continuity here when you put your leads on the metal. If you are reading continuity after you are 100% sure that you've put enough fire on it, just like that, where we started to get some blue ring around there, then you know it's bad. So that's another good way of telling if it's getting stuck. So after we have let that cool down a little bit, you should hear the pin let go, which means the disc is going to go flat again, closing that circuit. And there you go. You got continuity. But it's going to be the same thing with these rollout switches. They're going to have a higher temperature tolerance for those. And there we go. As you can see, right there, this is why it's called a manual rollout switch. It's a manual reset rollout switch. These are put into place for a very important reason. If it detects rollout, it's going to pop, which means you or the technician has to go up to the furnace and manually reset it. We're going to give it a minute to cool down, and then I'll show you what I'm talking about. Okay, so now that we've taken a minute to kind of let it cool down, you should be able to depress it, and you hear that click. You should be able to push that in and hear and feel a click. If these are bad, which they don't go out very often unless your machine's pretty old, they're going to keep popping, like constantly. And that means it's just not able to stay secure and it's letting go. But more often than not, and when I mean that, I mean like 90% of cases that I've seen, it's usually doing its job. And we'll get to that in just a minute. Also important to note, a high limit switch can also be doing its job. So when the board gives you a code for high limit, just like the other limits, you're going to take the wires off and jump them together. If it does work just fine, again, do not leave the wires like that. It's important that you don't. It's a safety hazard. It's a fire hazard. So don't burn your house down. If your high limit switch is bad, a pretty good indicator is even when you reset the power on your unit and let it sit for a little while, If you cut it back on and immediately both your main blower motor and your inducer motor come on, this is usually the culprit. Also, the board will kind of let you know, hey, bad high limit switch. So just to review, the two wires coming off of your high limit, whether it be your high limit, your rollout limits, your disc limits, you're going to remove those. Obviously, make sure the power is off before you do this, please. You're going to connect these two, bypassing the need for your limit switch to already have it closed in the unit. There we go. Now we've closed the line. Boop, see if it works just like normal. Now this doesn't always work for diagnosis, and we'll get to why. So a lot of people are going to have an upflow application, which means your blower is going to be here. It's going to go up through here, past your heat exchanger. It's going to hit your coils, which are up here, your evaporator coils. Now this is in your closet, if you're in a closet application. If you're downflow, you're going to take this and flip it, which means the air is going to blow under your home through floor vents instead of up through to your attic or wherever your ductwork is running for the supply. And here you can see, pretty typically, your high limit switch, which obviously looks like a normal disc limit there, which high limit switches can look like that. It's usually going to be, and as you can see, your heat exchanger here. Okay. That high limit is going to be along that wall, usually behind your gas valve. This will be your inducer motor, which should be the very first thing that comes on when you start your machine. Your pressure switch, and then your rollout switches should be along your burners. And depending on how many burners you have, will be how many rollout switches you're going to have. And again, you can have disc limits on your blower, whether it's secondary. I've even seen some primary on here, which is really bizarre, but engineers. So say you are getting a code for open high limit switch. You jump around it, everything seems to be working, boom, you're like, all right, it's this part. And again, you're gonna look for that temperature on there. This is a pretty high temperature high limit switch. It's 240. Most of them are kind of lower, around the 130 to 180 range. But if you do jump around that, it seems to work, everyone's happy, you buy a new one, you put it in there, and then a few hours later to a day or two later, it does it again. Boom, high limit switch open. Probably, if we think statistically, that's not going to be the case, which, what does that mean? Okay, really frustrating when, again, this thing is opening and your board is saying that it's opening, but it doesn't mean your board is bad. It means that the high limit is doing its job and your furnace cabin is overheating. What that means is you probably have low airflow here. And the most common reason for low airflow is your evaporator coils, which we can't see on this page. It's going to be in a separate encased box up here. A lot of you have A-shaped coils, some N, and maybe a slant depending on if you've got a wall unit, something like that. What that means is you need to clean your evaporator coils. And 99.99999% of the time, the people that come in here need to clean their evaporator coils. And I can't stress this enough because I get a lot of people that come in and they purchase one of these and lo and behold, it wasn't that to begin with. You might not see them back right away, it might be a little bit, but they're having the same problem. And their go-to is always the circuit board. I can't tell you how many times circuit boards I've seen come in here and tested that were not bad. That's always someone's first thought. And after about 15 years, really after about 10 years, that's, kind of a valid thing to think, but it's usually not right. And you'll know some indications. We'll go over those in a different video. The point of it is, if there's low airflow, it means, well, nothing can breathe in there. Your motor can't breathe, your blower, it's not pulling enough air through there to cool everything down enough to keep your machine on. Basically your machine's going, warning, warning. When that happens, it's the obvious here. You're gonna need to get into your evaporator coils and clean them. And a lot of coils, they're going to be in that separate box, whether you're at a horizontal application, you know, something like that, depending on which way your ductwork goes, right? And it'll be in a separate box. So sometimes there's going to be screws and whatnot you're going to have to take out of that housing. And we'll go over this later. I can kind of show you what an evaporator coil looks like and how to clean them and all that fun stuff. But needless to say, what you're going to do is clean those, and there's some awesome YouTube tutorials on there. It's a little bit of a pain in the butt. If you think you're not up for it, just call a technician, have them come out and clean it up. But I can guarantee you your machine is going to function 1,000 times better. So if you're kind of puzzled over something like that, you're having the same issues, that's probably your problem. So, I mean, honestly, it's really wise to keep your evaporator coils clean somewhere around every 2 to 3 years, give or take. And really good way to check that out is check your blower housing, which is going to be that guy down there. You're seeing a lot of crud in your motor, kind of around. You got some smudge, dirt, hair, lint, gross stuff, or in the blower wheel or here, then that's a really good indication you need to clean it. Also on your filters, if you're noticing you're having to replace your filters more often than usual, or if they're getting dirty much faster than you think they should be, it's probably time to check on those evaporator coils. So unlike your outdoor coils, your indoor coils can be cleaned once every few years. That kind of gives you an idea of things you need to look for, the functionality of these limits, and how they work. And these little guys here, your rollout switches, when they pop like that, if you do replace them, and guess what, the new one does the same thing, then again, that's probably indication that they are doing their job and it's overheating. Whether that be flame rollout, which is bad, means it's time to get a new heat exchanger. And without having a combustion analyzer, which is a tool to just measure carbon monoxide and whatnot, see if it's got safe levels, because everybody has a little bit of carbon monoxide in their home, whether they like to think about it or not. You're not going to bring someone out there to do that. It's really good to get a carbon monoxide detector, preferably one that has a low parts per million detector, and really under 10 would be awesome. They're not too expensive and it's kind of peace of mind, but I mean, just getting one is a good idea. Kind of keep those near your return air vents in your home. That kind of summarizes a few things on these guys. Don't always assume that they're bad. If it is popping and whatnot, like I said, jump around them. It seems to be functioning. There's a chance this is bad, but it can also be doing its job. So if you do replace them and you're noticing that it's still doing the same thing, probably need to look into that further. So there we go. Limit switches. For videos like these and any more, just subscribe to our channel and check out some more of these. Bye guys.